In this video, we're going to practice factoring trinomials into two binomials, and eventually we'll use this factoring to solve for zeros for our quadratic functions to find out where they cross the x-axis. But for today, we're going to take our trinomial and, like I said, factor it into two binomials. So in order to do that, we need our product of our two numbers to equal our c, and we need our sum of our two numbers, and you'll see what this means in a minute. Sum of our two numbers to equal b. So what does this mean? Our c value in this case is 6, and our b value in this case is 5. So what I like to do is make a nice little t-chart here. And I know that the sum of, or the product of my numbers, which is when I multiply them together, has to be 6. And when I add my two numbers, these two factors together, they have to equal 5. So what I do first is think of all the factors that I can think of 6. So the factors of 6 might be 1 and 6, maybe it's 2 and 3. And in this case, that's all the factors I have. Well, next thing I need to do is, these are the two factors that multiply to 6. These two factors also multiply to 6. But remember, they not only have to multiply to 6, our c, they also have to add to our b. So you'll see what I mean in a minute. If I add these two together, 1 plus 6 is 7. They do not add up to 5. If I add 2 plus 3, oh look at that, that equals 5. So this is the correct answer right here. But again, like I said, I'm going to make these into two binomials. So this factors out to be x, these are positive numbers, x plus 2 times x plus 3. And that is my answer. Let's look over at our next one. Again, I want my two factors to multiply to be 1, and they have to add to be 2. Well, if I make a t-chart here, and again I want them to multiply to be 1, and I want them to add to be 2. And you're thinking in your head, well, there's only two factors of 1. That would be 1 and 1. No other numbers multiply to be 1. If I look at this, 1 plus 1, and I add them together, that equals 2. That's my correct answer. So my answer in factored form would be x plus 1 times x plus 1. Looking at my next example, my c value here, oh, we have to be careful, is negative 10. And my b value is negative 3. The tricky part about this one is that I have to multiply to be a negative, and they have to add to be a negative. In fact, they have to multiply to be negative 10 and add to be negative 3. Now in order to multiply to be a negative number, I need one positive, one negative. So let's think of all the factors of 10, then we'll make one negative, one positive. So I could have 1 and 10, so I can think of negative 1 and positive 10, or I could do it backwards, 1 and negative 10. My other factors of 10 would be 2 and 5, so I could do negative 2 and positive 5, or I could do positive 2 and negative 5. Because remember, one of my factors has to be negative to multiply to be a negative number. Now let's add these together and see which pair adds to be negative 3. Negative 1 plus 10 is 9. That doesn't work. 1 plus negative 10 is negative 9. That doesn't work. Negative 2 plus 5 is positive 3. Oh, we know we're getting close, but that doesn't equal negative 3. 2 plus negative 5 is negative 3. That's our answer right there. So keep in mind the 2 is positive and the 5 is negative. So I write x plus 2 as one factor and x minus 5 as my other factor. Looking at my next example, I need my two numbers to multiply to be positive 9, but they need to add to be negative 10. This is a tricky one. They need to multiply to be 9, and they need to add to be negative 10. Now, the tricky part about this is in order to multiply to be 9, I could do 1 and 9, or I could do 3 and 3. The problem is when I multiply two positives, that equals a positive. Or two positives here, when I multiply them, they equal positive. But there's no way I will ever make a negative number when I add them together. The other way I can make a positive number when I multiply two numbers together is by making them both negative, because a negative times a negative equals a positive. So if I have negative 1 times negative 9, that's positive 9. Negative 3 times negative 3 is positive 9. And let's see which one adds to negative 10. Well, negative 1 plus negative 9, that's actually negative 10. Negative 3 plus negative 3 is negative 6. So that's not our answer. Keeping in mind we have two negative numbers. We have x minus 1 as one of our factors, and x minus 9 as my other factor. In my next example, I need my two numbers. I need my two numbers to multiply to be 20. And they need to have a sum of 12. So thinking of all the factors, and again these are both positive, that makes it a little bit easier. Let's start with 1. 1 times 20 is 20. 2 times 10 is 20. 20 doesn't divide by 3, but 4 times 5 is 20. So I'm looking at all these factors right here, which pair adds up to 12? If I look 1 plus 20, that's 21. That's out. 2 plus 10 is 12. That's the right answer, because 4 plus 5 is 9, and that one doesn't work. So again, my answer, since they're both positive, x plus 2, x plus 10. Looking at my next example, again I have a positive product and a positive sum. So I have a product of 12 and a sum of 8. Again, starting with 1, thinking of all the factors of 12, I have 1 and 12, 2 and 6, and I have 3 and 4. Again, I have to look for which one not only multiplies to 12, but adds to 8. 1 plus 12 is 13. That doesn't work. 2 plus 6 is 8. That's our pair, because 3 plus 4 equals 7. That doesn't work. So again, they're both positive, x plus 2, x plus 6. In my next example, I want to multiply to be a negative 16 and add to be a negative 6. My product has to be negative 16, and my sum has to be negative 6. Now remember, when I'm multiplying to be a negative, when I need a negative product, I need one positive, one negative number. So I could make it negative 1 and 16, 1 and negative 16. I could make it negative 2 and 8, or I could make it 2 and negative 8. Those are my factors of 16. So now let's add them together to see which one adds to negative 6. Negative 1 plus 16 is 15. Out. 1 minus 16, negative 15. Out. Negative 2 plus 8 is positive 6. Still not there, but we're close. 2 plus negative 8 is negative 6. So that's my answer right there. The 2 is positive, x plus 2. The 8 is negative, x minus 8. Alright. In my next example, I have another tricky one, because I need my product to be positive 16 and my sum to be negative 10. Remember, if I need a positive product and a negative sum, this is the tricky one, a positive product, negative sum, they both have to be negative. So positive product, negative sum, both negative. That's your hint. That's the tricky ones. Alright, so what are my factors of 16? Well, I have 1 and 6. Oh, we have to make them both negative. I just said that. Negative 1, negative 16. Negative 2 and negative 8. And negative 4 and negative 4. So which ones add to negative 10? Well, negative 1 plus negative 16, that's negative 17. Out. Negative 2 plus negative 10 is, or negative 2 plus negative 8, sorry, is negative 10. That's actually my answer. Let's just check this one. Negative 4 plus negative 4 is negative 8. Doesn't work. So since they're both negative, we have to make them minuses inside. X minus 2, x minus 8. Alright, in my next set of directions, what I need to do is factor out the greatest common factor. So I need to find a number that 36 and 18 both divide by. Well, in this case, 36 and 18 divide by lots of different numbers, but they actually divide by 18. Now, if you notice, this one has an x squared, and this one also has an x, so I can actually take an x out of both of them. If I do 36 divided by 18, that gives me 2. And since I had 2 x's, and I took one out here, I still have one left inside. Plus, if I do 18 divided by 18, that's 1. And if I had one x to begin with and I took one x out, there's no x's left to put inside here. If I were to multiply this back out, 18x times 2x, 18 times 2 is 36, x times x is x squared, 18x times 1 is 18x. So that actually, if we distribute that back out, that's going to be correct. Alright, next one, 14x squared plus 7x. I need to find the greatest common factor between 14 and 7. In other words, what do 14 and 7 both divide by? Well, 14 and 7 both divide by 7, and since this has 2 x's, this has 1 x, I can take out 1 x. So when I do 14 divided by 7, that's 2, and if I start with 2 x's and I divide out 1, I still have an x left over. 7 divided by 7 is positive 1, and if I started with 1x and divide out 1x, I have 0 x's left to put in. Next one, 30x squared divided by 20x, or minus 20x. Now I need to find a greatest common factor between 30 and 20. So a number that 30 and 20 can both divide by would be 10. I have an x squared and an x again, so I can take out 1x out of both of those. 30 divided by 10 is 3. X squared, and I divide out 1x, that's going to be x. Put my minus sign in here. 20 divided by 10 is 2. And if I started with 1x and I divided out an x, there's no x's to put in here. That's my final answer. If I have 25x squared and minus 10x, and I want to factor out my greatest common factor between 25 and 10, I know that both 25 and 10 divide by 5, so I'm going to take out a 5. If this is an x squared and this is an x, I can take an x out, 1x out of both. Then I just divide each of these by my term that I'm pulling out. So 25 divided by 5 is 5. I had x squared and I divided x. I have 1x left inside. I have negative 10 divided by 5, that's negative 2. And if I started with 1x, I divided out an x. There's no x's left to put inside. So that would be my final answer. Now it's your turn to practice.